Assignment number 95, that's going to be due tomorrow. It's in the problem set, all the usual things. Alright, so while I take attendance and take care of some business, there are 4 problems on the board. You have 3 minutes, completely on your own, no help from any of the friends near you to work through all 4 of those problems. I have no doubt you can do it. I want to be a proud papa. I got it. All right. Homework over here. Yes, you are not able to do that one yet, but it's coming. It's going to happen. I'm going to mark Carmen as absent, and then she's going to show up. So, have we seen Carmen this morning?
No.
Oh, absent. Sorry for the super short notice. We're not going to be in class today. You're really bad over the weekend. Oh, okay.
So responsible. I don't think I'll listen today.
Focus. You've got 2 minutes left. Don't forget Charlie. Time's up. Why don't you have a quick conversation with somebody near you? Check them out, see how you did. Some of these should be way easy, others maybe not so much. Alright, friends. Somebody tell me one that you feel really good about. It could be any one of these 4, I don't care. One that you feel really good about and why you feel really good. David?
The first one.
The very first one. You feel really good about because?
We've seen it a lot of times.
You've seen this one a lot. This should be on the I have it memorized list. What function do you know of that has 1 over 2 square roots of x as its derivative?
That's square root of x.
This should be square root of x, like it, don't love it.
Plus c.
Plus c. Okay, good. Thank you, David. Other ones that we're feeling pretty good about. Liz, what do you think?
It's number 2/5 x That's 5 over 2 plus
I completely agree with you. It is 2/5 x to the 5 halves, but how did you actually go about doing that?
Oh, I put x squared, put x to the 1/2, and then I combine those two.
Okay, you said x squared, but I think what you really meant was square root of x?
Yeah. And then that would be x to the 3, 2.
Okay, because you are multiplying these two, they have the same base, and the rule is you add the exponents. So x to the 3/2 dx, and Lewis, how do you finish that off?
And then you just add 1 to the,
Add 1 to the power, 3/2 plus 1 is indeed 5/2. Add 1 to the power.
and then you divide by, I'm multiplying times 5 over, times 2 over 5.
Right, times 2 over 5. What you're going to say the first time is right. You add 1 to the power, and then you divide by the new power, but to divide by 5 over 2 is the same as to multiply by 2 over 5 plus Charlie. How many of you guys got the first two right? Okay. Any brave soul for number 3? What did you do? Any brave soul for number 4? Stephen, what are you going to do at number 4?
Wait, can you tell me, like, I'm gonna tell you an answer, can you tell me if I'm right?
Just tell me what you did. Be brave. Jump out there in traffic.
Alright, basically, for u, well, I did substitution, and for u, I did x squared plus 2, and for du over dx, it equals 2x.
Wait, so you're saying over here, you said let u equal x squared plus 2, so you're thinking like integration by substitution? And so then the du dx is going to be 2x.
Yes. And then what I did is, so I did u to the power of 4.
Wait, are you on number 3 or number 4?
Wait, number 3, right?
Number 3.
Okay.
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 Was everyone else with me? He said number 4 the first time, right?
Yeah.
Yeah.
Oh wait,
All right.
no, I made number
Oh, yes, you did. Okay. So for number 3,
I was right.
u is, number 3, u is x squared plus 2.
Yes.
Du dx is equal to 2x. So my question to you all is that the right way to go with number 3? Should this work?
Let's say,
Yes.
You know it's going to work if you see the baby and derivative of the baby in your integrand. Do we have both?
Oh.
We can make one.
You can make.
Right, through multiplication, through some clever multiplication, you can get the derivative of the baby to show up. What you'd have to do is you'd multiply both sides by a half. So 1/2 du dx is equal to x. I didn't leave myself enough space here. But in the rewrite process, you're going to rewrite x as 1/2 du dx. Instead of x squared plus 2 to the 4th, we're going to call that u to the 4th. And we're multiplying by the dx. And at some point, we're just going to start getting really fast at that and see that those guys are going to cancel each other out. The next thing that you're going to do, you're probably going to pull that 1/2 out in front. So we've got 1/2 the integral of u to the 4th du. And the question is that something that we can integrate?
Yes.
Right, this is a power rule problem now where we're going to add 1 to the power and divide by the new power just like Lewis told us to do earlier. So it's going to be u to the 5th, 1/5 of that. Now you multiply by that 1/2 that's on the outside, still plus Charlie. So 1/10 u to the 5th plus c, final answer, 1/10 x squared plus 2 to the 5th plus Charlie. Did anybody actually get that one? Okay, so Stephen, when you realized we were talking about number 3, not number 4,
Yeah.
you get that. Okay, I want you to have a strategy conversation with somebody near you. What are you going to do at number 4?
skip to the baby would be x squared plus
What are you going to do at number 4? Number 4 should be a little bit different.
So 0 multiplying thing by 0 multiplying thing by
So I'm curious, what's different with number 4? What's the problem with number 4?
The derivative is nowhere to be found.
Right, if I identified the baby as x squared plus 2, the derivative would be 2x, and that's not showing up anywhere in the integrand. This problem is not an integration by substitution question. We can't solve this using integration by substitution. There are, however, other legal things that we could do. Anybody see any other legal things that you could do? Substitution doesn't work. Lewis, what legally could you do though?
Put x squared plus 2 times x squared plus 2.
Okay, so you're going to change the integrand to be x squared plus 2 times x squared plus 2. And why is that better? What can you do now? X squared plus 2 times x squared plus 2. So let's help them out. What can you do now?
You can multiply them out to get x to the 4th plus 4x squared plus 4.
Right, the benefit of writing it out this way is you can actually just distribute. And now if I ask you guys to integrate this, Myra, what are we going to get? Integral of x to the 4th plus 4x squared plus 4. What are you going to get for me?
X to the power of 5 over 5.
Yeah.
4x to the power of 3 over 3.
Plus 4/3 x cubed, yeah.
Plus 4x.
Plus 4x
Plus c.
plus c. Okay. So over the course of the next week, it's not going to be substitution all the time. Substitution is a powerful tool in your toolbox, but sometimes it's just going to be inspection. You're just going to look at it and you're going to know what the integral is. Other times you're going to have to do a little bit of algebra manipulation. That's kind of what's happening in 2 and 4. And sometimes substitution is going to be the way to go. Everybody mostly okay? All right, here's what I'm going to ask you to do. Unfortunately, Carmen blew it for us. I was like, we have an even number of people. We can make this work. I want you to get some practice, please. So somebody's going to have to work. Someone's going to get to work with the camera. What you have is you have the next 8 minutes to work with somebody you are not currently sitting with. Everyone needs to find a new partner. Whoever the last person to partner up is, you're with the camera.
No! What are you doing?
You cannot be partnered with somebody you normally sit with. Whoever's the last person to partner up, you get the camera. Don't let it be Giselle.
I mean,
Don't let it
we got left out all 3 of us.
That's because the 3 of you move slowly. All right, Stephen, you get to be with Carmen. You two get to be together. All right. One of you is partner A. The other is partner B. Partner A, your job is to figure out the indefinite integral. When you're done, give your paper to partner B so that they can give you some feedback. So partner A, raise your hand. Partner A, you're starting on this problem. You're going to work through this problem on your own. It's going to be an integration by substitution question. Partner B, while they're doing that one, you're doing this one. When you guys are ready, swap papers, provide feedback. Hopefully you can do round 1 and round 2. We'll talk in a few minutes. I will be playing the role of Carmen today, so that Stephen has someone's paper to switch with. I'm looking for really good notation. How are you doing so far? Did you watch a video from last year? So do dx equals 6x, I agree. And then you multiply both sides by 1/6. Don't use another equal sign. So let's erase that equal sign. Because what you're saying is this was originally true. I multiplied everything by 1/6, and now I'm getting this new thing over here. Okay? When you're ready, switch papers with your partner and get some feedback on them. I care greatly about notation. Yeah.
You need the restroom. You need the restroom.
Can you check with Andrew and get some feedback from him?
Wait, oh, there we go.
Not.
Oh,
The antiderivative
Yeah.
of e to the u is not u times e to the u. What's the antiderivative of e to the x? Just e to the x. Not x e to the x. So it's e to the x.
Oh, x
So in
cubed,
this case, e to the u.
x cubed plus
nah, that's
5x.
too much.
No, but now the other problem is don't stop here.
How do you,
Why are you not going to stop here? The original problem was in terms of x. It's fine. It's in terms of the x. Yeah. Oh. Chair. All right, solutions to round one. Here they come. These are what your final answers ought to look like. 1/6 e to the 3x squared minus 5 plus Charlie. With indefinite integrals, if you start with x, your final answer has to be in terms of x. You do the substitution trick in the middle just to make it a little bit easier, but ultimately your final answer is going to be in terms of x. For partner B, u was the denominator, you took the derivative, you multiplied by 1/6. 1/6 du over u, factor out the 1/6. Integral of 1 over u is natural log of the absolute value of u, and that's what you ought to get. Okay, round two, one more time. Steven.
Oh,
Steven, why don't you partner up with Andrew?
thank you.
Same partner,
Oh, okay.
but this time why don't you partner up with Andrew?
Good.
You good? And you guys are done. I mean, what you're probably going to find is integration of substitution. It's just there's a pattern that you follow. Yeah, round two. If you were partner A before, you're still partner A. Whenever you're ready, swap papers with your partner so they can give you some feedback on your work. Andrew, are you partner A or partner B? Okay, so now you're going to figure out how to integrate this thing.
I would say yes if I actually.
Good. Now, be careful. It's not DUDF. It's going to be DUD theta. Because theta is the variable here. And then the variable size don't matter. It'll take about one more minute.
You would be 2 7. D equals 2 cosine.
It's small, but it's important. D theta, not dx.
Oh.
What I don't understand is how you went from u, cube root of u, to u minus 1 over 1/3.
Oh wait, no. Just you.
All right, spoilers, here they come. All right, I think for the most part, all the partner A's and partner B's selected the right baby. In this case, 2 sine theta minus 1. Then the derivative is, I chose to write this a different way. Sometimes I write du d theta is going to be 2 cosine theta, or I multiply d theta to both sides. So du is 2 cosine theta d theta. Either way, I have to multiply by 1/2, so I get my new integral, which is 1/2 du, cube your du in the denominator. That cube your du in the denominator is the same as u to the negative 1/3. I'm going to add 1 to the power, I'm going to divide by the new power, so now I've got 3/4 u to the 2/3 power plus Charlie for partner A. How many of you guys came up with this one? One person. Okay, for partner B, u is going to be 1 plus sine of 2x. Maybe you probably wrote du dx is equal to 2 cosine of 2x. You're going to multiply both sides by 1/2. Your integral becomes 1/2 du over u squared. Having the u squared in the denominator, I'm going to rewrite as u to the negative 2. I'm going to add 1 to the power. I'm going to divide by the new power. So I'd have negative 1/2, 1 plus sine of 2x, the whole thing raised to the negative 1 power plus Charlie. That's the same thing as putting the 1 plus sine 2x in the denominator. And then plus Charlie. How are folks feeling with integration by substitution?
The only thing is like recognizing when it would be smart.
When it would be smart to use
Yeah.
integration by substitution? The general rule of thumb is the uglier the integrand, the more stuff that's in there, the more likely it is integration by substitution is the way to go. It's not a guarantee, but the more stuff there is, the more likely it is substitution is going to be the way to go. Myra, you're good? Boys on this, men on this side, I'm sorry, there are no boys in Calculus BC. All right, so now it's time to push your thinking a little bit more. Little bit more. Take a gander at what I've got for you on page 26. I hope I left enough room. What's different? Oh, perfect. Lewis is back. Anybody notice any difference with these problems on page 26?
They have
The definite integral.
They have numbers, as Myra said. I heard Celeste say they are definite integrals. Oh my God, it's like you're in my heart. If I had one.
I'm in the hole that's supposed to be yours.
Yes, the hole. Yeah, you're normally in the hole and you're trying to dig out. Good idea. Is everybody okay that these are definite integrals. These are definite integrals. Lewis, are you okay? All right, so we've got a definite integral, which means that in terms of a final answer, what am I looking for?
A number.
We're going to get a number this time. In fact, if you have access to your calculator, take your calculator out. So I want to make sure that I'm not lying to you with what we're going to do. Oh, David's back in the hole. All right, so here's the thing. When it comes to definite integrals, it's not that different. It truly is not that different. But, let's see. Take a look at this first one. Does this look to you, Andrew, like a good candidate for integration by substitution? Yeah? Why? I completely agree with you, but tell me why.
Because you can see the baby.
You see the baby already. Where's the baby?
About x squared plus 1.
You see the baby is x squared plus 1, but that doesn't mean integration by substitution. What else?
And then you find du dx.
If I find du dx is
2x.
2x. Do we see the derivative of the baby in the integral as well?
Not yet.
Not quite yet. What are you going to do to get there?
Multiply it by 1/2.
Multiply by a half, so now I'm going to get 1/2 of du dx is equal to x. Is everybody okay that this seems to be good? This is a good candidate for integration by substitution. And I'm always a big fan of like, let me rewrite in a different color. Instead of x, I'm going to write this as 1/2 du dx. Instead of x squared plus 1 cubed, I'm going to write that as u cubed. And the dx still out there. The dx that I'm dividing by here, the dx I'm multiplying by there, those guys are going to cancel out. This is good. All the right things are happening. There is something, however, that's a little bit different that we need to take care of. When it comes to a definite integral problem, you not only have to change the integrand from x's over to u's, you have to change what David said, those limits of integration. Those limits of integration are x values. We're saying x is equal to 0 and x is equal to 1. I need to change those limits of integration over here as well. So the good news is you already know that x is equal to 0 and you know that x is equal to 1. And you've got, I like to think about this as like my bridge. It's the connector between x's and u's. So how do I find the new u values, Polynomial?
You just opt for the values.
Right, you just got to plug them in. So if x is equal to 0, what's u?
1.
1. And if x is equal to 1? U is 2. And for those of you that are like, where did those numbers just come from? If x is equal to 0, then u is 0 squared plus 1, which is 1. If x is equal to 1, then u is equal to 1 squared plus 1, which is 2. I want to see those limits of integration changing. They have to change. Have to change. Because here's what's going to happen. Sometimes, all they're going to ask you to do is rewrite your integral. I'm going to clean this up a little bit. I've got the 1/2. That u cubed is in the denominator. So I'm probably better off rewriting it as u to the negative third. And then the du. There have been times on the AP exam where all they've wanted you to do is rewrite it in terms of u and not actually do the evaluation. So this could be your final answer. If it's not the final answer, if what they want is a number, well then let's finish it off. Things that we can do to finish this problem off?
Move the 1/2 in front.
We're going to take that 1/2 out in front. That's legal because it's a constant. So we've got 1/2 the integral from 1 to 2 of u to the negative third du. I need to integrate u to the negative third du. I think some of you guys are already like on the board. You're doing this. You know exactly what to do. Ayla, do you feel pretty good about what we're going to do next year?
Yes, you can plug in the YouTube.
I want to be careful. I don't think we're ready to plug in yet because we still have to find an integral. Do you know what the integral of u to the negative third is going to be? I need to integrate u to a power. What does that power rule tell you to do?
Bring the power down, take 1 from the power, subtract 1 from the power.
Hold on, I think you're confusing derivatives and integrals. We're doing an integral. So the integral of u to the negative third, you don't want to take the power down and multiply. You want to add 1 to the power. So what's the new integral going to be?
U plus u.
To the negative 2
U to the negative 2.
times.
So you've added 1 to the power, and then divide by the new power, which is the same as multiplying by negative a half. Now be careful, because that's your integral, and you still got to multiply by a half. Take care of that. And we still need to evaluate from 1 to 2. So if I want to finish this off, I'll get negative 1/4 u to the negative 2 from 1 to 2, which is the same as negative 1/4 u squared from 1 to 2. What's different with definite integrals, there's a difference in the beginning in that you're going to change your limits of integration. It's not just change the integrand, you got to change the whole problem. The good news though, at the end of this problem, all you're interested in is what's the number, what's the numerical value. So we've changed everything over to be in terms of u. These guys here are in terms of u. We're just going to plug them in and evaluate and be done. There's no going back to x's like we usually do. So if I plug everything in, I should get negative 1/4 times 2 squared is 16, minus negative 1/4. And if I simplify that correctly, I think we're going to get 3/16. Now let's make sure I'm not lying to you. Actually, like, plug this guy into your calculator. Let's make sure that you're getting something that's actually equal to 3/16.
Go to the book thingy?
Or you can hit menu, calculus, numerical integral, and then plug all this stuff in. Menu, calc, numerical integral, hit enter. I think you're forgetting to qubit. Okay, and we're getting 0.1875 as a decimal, and if you change 3/16 to a decimal, good news, 0.1875. Pretty mostly okay? It's almost like I planned it, almost. Okay, so keep in mind, the only thing different, the only difference with definite integrals with substitution is you change the limits of integration as well. Everything else is the same. All right, so with that said, show me what you guys can do at number 2. We'll talk in a minute.
You need a 10. I don't know where to start.
Oh, I'm tricky. I'm tricky. Oh, I'm tricky. If you're looking for integration by substitution, you're like, what could the baby be? Where's the derivative? There doesn't seem to be a lot of stuff here. We've seen 3,
And then cosine.
4 people off to a good start.
So there's a negative.
Palomone, what's your advice to all the friends that might be stuck a little bit right now?
We turn tan into sine of cos.
Okay, rewrite tangent of theta as sine of theta over cosine of theta. And my question to you, Palomone, is that legal?
Yes.
Is that legal? Sure. Is that better?
Yes.
Lewis, why is it better?
Because now you have a baby and
Now you have a baby and you have a derivative of the baby, right? So what's your guess for the baby? So here's the thing. I see Stephen said, I want the baby to be the sine of theta. Everyone else seems to be going with the baby's going to be the cosine of theta. Check out what's going to happen. Du d theta is then going to be, what, negative sine of theta? And I like having the sine of theta up here in the numerator. I can get this to show up by just multiplying by negative 1. So negative 1 du d theta is equal to sine theta. When I do the rewrite, Sine of theta is up in the numerator, so I'm going to have -1 du d theta. Cosine of theta is in the denominator. That's where my u is. And there's the d theta. And as expected, the d thetas cancel each other out. A little bit of trickiness here. When I tell you that theta is equal to 0 and theta is equal to pi over 4, you need to find the u values, which means find the cosine of 0 and find the cosine of pi over 4. And the cosine of 0 is 1, and the cosine of pi over 4?
Square root of 2 over 3.
Wait, the square root of 2 over 3?
Two.
2? Okay, that was a really good joke for a Monday. Yeah. Ha 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 ha. Alright, so we're going from 0 to pi over 4, so now we're going from 1 to square root of 2 over 2. Well, what's left? I've got an integral from 1 to the square root of 2 over 2, -1 over u du, and I would hope that that's something that everybody feels really comfortable with. Lewis, what's the integral going to be?
Natural log of d.
I almost love it.
Okay. Negative.
First of all, there's a negative in here, so there's a negative out there. Second of all, the integral of 1 over u is not natural log of u.
Let's see. And natural log of x. Absolutely.
Natural log of the absolute value of u. And then we evaluate from 1 to the square root of 2 over 2. We plug them in. Negative natural log square root of 2 over 2 minus negative natural log of 1. That's a good answer for free response. For multiple choice, you're not going to see that as a choice. Why not? What do I expect you to know in the multiple choice in terms of simplifying this? There's something. Celeste, what do you see?
The natural log of 1 is
What is the natural log of 1?
0.
So this whole part over here is just 0. And so a good final answer is negative natural log of the square root of 2 over 2. Lewis, the reason I'm not worrying about the absolute value bars here, square root of 2 over 2 is already positive, so I don't need the absolute value bars. So that would be final answer. Tonight's homework is finally going to get you some practice with integration by substitution. Some definite integrals, some indefinite integrals. What I want you guys to do is take a couple minutes, see what you can do. On the page 27, there's 2 problems at the top. My goal is for you to get hopefully both, but at least one of them done. Once you've evaluated the definite integral by hand, feel free to check it on your calculator to make sure you're doing this right. worry about simplifying final answers. That's all right. You just want to make sure there's no need to write it. It's not wrong if you do, but you won't. So you use x squared plus 9, that's the stuff underneath the bracket. 2x. So like, the problem is when you do the rewrite, you forget about this square root. Okay. So we've already said from now on, like when we say u means cosine of theta.
So we just do it.
Exactly. Okay. Hey man. Not quite. Okay, what happened to the one? Another one that's already
Oh.
2 yes. Yeah. What was I doing? Okay, so I like most of what's here. Here's what I don't like. Your limits of integration. When you change your limits of integration, originally you're saying x equals 0 and x equals 4.
Oh, I did. Oh, yeah.
And you gotta remember u is x squared plus 9.
So let's meet
I've got a
I see
slightly
it, 'cause I messed
different
up.
answer, but it could be that I'm wrong. I hope I'm not wrong.
Oh, it's better man on it. I see it's a even in the bottom half.
3 halves. I agree with that.
It's not.
125. Wait.
You skipped like the first half.
Okay.
Is it correct to square root first?
It's 1 line.
No, yeah, it's the yes, and but the problem is 5 cubed is 125. It's not 100.
It's not too much. Because I was like, you're forgetting the.
Alrighty, friends. There's 1 and 2. Let me focus on number 1 first. So from walking around, everybody seems to be doing pretty well just with the process of identifying the baby, finding the derivative of the baby. That's all pretty good. Changing the limits of integration over, and eventually you're going to get 1/2 the integral from 9 to 25 of u to the 1/2 du. Is everybody feeling okay with getting to that part? Okay, and then the antiderivative of u to the 1/2, add 1 to the power, divide by the new power. Don't forget that 1/2 that's out in front that you're going to multiply by, and then you're going to evaluate from 9 to 25. If all goes well and you simplify, you're going to get to 98 over 3. I'm not too terribly worried about the simplifying tonight on the homework. I do want you to practice with that. But keep in mind, if it was free response, you could stop as soon as you get to everything is a number. There's no need to go and simplify any further. For those of you that had a chance to do number 2, again, the baby, pretty obvious. U is going to be x minus 9. You're going to take the derivative. You're going to rewrite all the stuff. Okay, we've got 6 minutes left. And I want to look at question number 3. This question number 3 may not, well, let's see. Let's see. Thoughts for question number 3? It's done. Okay. Is everyone relatively convinced that this should be integration by substitution? Palamon, convince me that you should be thinking about integration by substitution here.
Like I said, the more messy it is, the more powerful.
The messier your integrand is, the more likely integration by substitution is going to be the thing to do. So if that's the case, I need a baby. What's a good baby? What's a good guess for the baby? Maybe 3x squared minus 5x plus 2. And if that's the case, then the derivative is 6x minus 5. I don't know of any way to multiply 6x minus 5 by anything to get x plus 2. I might think, oh, multiply by 1/6, but then I'm going to get x minus 5/6, not x plus 2. That didn't work. Some people might say, well, what if I switch it and I let u equal x plus 2? Well, then the derivative of the baby is just 1. OMG, what's going on there? I don't know. So let me offer up something from pre-calculus that might be helpful.
They just
something
split
out,
up
right?
the top and then get rid of the bottom.
Oh, you mean like factor and cancel? If the top could factor, maybe. Maybe. It doesn't. I know, I built it this way. There's something else that you learned in pre-calculus back in like October of last year that involved division.
So you mean October of 2 years ago?
I mean October of last year.
When we
It was-
was
October, whatever. October of junior year.
He said, oh, whatever.
Division.
Oh.
Dividing polynomials. Because what I'm asking you to do, I'm gonna present it 2 different ways. What this problem really says is take 3x squared minus 5x plus 2 and divide it by x plus 2. What you could do, if you remember, it's called synthetic division.
The leftovers you
You start by, you would put not positive 2, but negative 2 inside of the box. And then you list the coefficients, starting with the highest degree, so 3, negative 5, positive 2. With synthetic division, you bring the 3 down in front, negative 2 times, stay with me, bring down the 3, negative 2 times 3 is negative 6, you add those together, negative 11. Negative 2 times negative 11 is 22, add those together, you get 24.
We didn't learn this.
What this means is you have 3x minus 11 plus 24 divided by x plus 2 is your new integrand.
I remember the x divided by
Hey
x
Steven,
plus
when you
2.
find the video on synthetic division, can you send it to me?
same here.
Okay. If this isn't the way that you remember Mr. Link teaching you,
It's
It's
not.
never seen that before.
No.
No.
Did you guys do like the big box?
Yeah.
Yes.
And then you like filled in like the color?
Yes.
Okay. All right.
And I think
Okay, so you would do something like, okay, what am I doing? I'm dividing by x plus 2.
that.
And if my goal is to get 3x squared, then it must be that this guy has a length of 3x. And so this is 3x squared. 3x times 2 is 6x. Well, that's nice, but what I'm really after is negative 5x, so I'd have to put a negative 11x up here. X times negative 11 is negative 11x. Negative 11 times 2 is negative 22. I have negative 22, but I need to get to 2, so I'm going to have a remainder of 24. I still get 3x minus 11 plus 24 over x plus 2. Is this the way that we remember doing it?
Yes.
Yes.
Okay. All right. Either way, you still need to integrate from 1 to 3.
I got it.
Okay. So I want to adjust the homework. There is a problem.
Okay, cool. What's the
Problem number 5. Do not do.
That sounds right.
Okay, so assignment number 95, the whole thing is due tomorrow with the exception of problem number 5. We'll talk about the division part tomorrow. I thought Mr. Link taught you guys synthetic division. No, or is it that you learned in Algebra 2 how to do it with the box?
That-
With Mr.
Yeah, learn in
Kurth.
algebra 2 how to do with the
I'm
box.
trying to teach them.
I bet in Algebra 2, Mr. Kurth taught you guys the box.
Yes.
But I swear